this new video. In this video, I'm going to discuss 10 physics problems of AAI ATC 2021 paper. I hope you will enjoy it.
So in the sixth problem, the question is, if a moving point possesses simultaneously velocities which are represented in magnitude and direction by the dash of a parallelogram drawn from a point, they are equivalent to a velocity which is represented in magnitude and direction by the dash of the parallelogram passing through the point. So this question basically asks about the parallelogram addition rule of two vector quantities. That is, if the two sides of a parallelogram represent a vector v1 and v2, then we can complete the parallelogram and the diagonal of this parallelogram will represent the resultant vector of the two vectors v1 and v2. So the answer is option D. If two sides of the parallelogram represents two vectors, then its diagonal will represent the resultant vector. The next question says that a galvanometer coil has a resistance 20 ohm and it can show its full deflection for a current 2 milliampere. How can one convert this galvanometer to an ammeter which can measure up to 6 ampere current? So as we know, to make a galvanometer an ammeter, one need to add a shunt, that is a small resistance which is in the parallel to the galvanometer. So we can afford only 2 milliampere current through this galvanometer. So if I want to measure a 6 ampere current, then only 2 milliampere current will go through the galvanometer. Rest of the 5.998 ampere current must go through the shunt. So if it has a resistance R, then we know the potential difference between A and B can be written as V, which is the current through the galvanometer times the resistance of the galvanometer, and the same potential is current through the shunt into the resistance of the shunt R. So we can take ratios of this. Ig Rg by Is is the resistance of the shunt. So putting the values, Ig is 2 milliampere, the resistance is 20 ohm, and the current through the shunt is 5.998 ampere. So you can take, for calculational simplicity, you can take 5.998 as 6. So we will have 40 by 6 milli ohm, that is equal to 6.7 almost. So option C is the correct answer. So for question 8, as we know from the continuity equation, as we know from the boundary condition of electrostatic field, the perpendicular component of electrostatic field above a charge plate minus the perpendicular component below the charge plate is sigma by epsilon naught, where sigma is the charge density of the charge plate. So using this relation, 18 minus 14 is sigma by epsilon. So sigma is 4 epsilon. Option D is correct. In the question number 9, the question says an alpha particle with kinetic energy 20 mega electron volt is heading towards a tin nucleus which has atomic number 50. So we need to calculate the distance of closest approach. So when the alpha particle is very far away from the nucleus, it has only kinetic energy and no potential energy, because the electrostatic potential, because due to this nucleus, is very small because of the distance. So initial energy I of the alpha particle is 20 MeV. Now when it comes to the turning point, the alpha particle has zero kinetic energy because it stops for a moment and it then retraces its paths back. So in this point, the alpha particle and the nucleus, the system, has only the potential energy, which is the electrostatic potential energy 1 by 4 pi epsilon 0 50 E. The charge of the alpha particle is 2 times the charge of the electron and divided by R. So according to the energy conservation, EI must be equal to U, but you have to remember that this is in electron volts, but this is in joules. So we need to convert the electron volts to joule. So this must be equal to 20. For mega it's 10 to the 6. For electron volt it's 1.602 into 10 to the power minus 19. So that 1.602 into 10 to the power minus 19 will cancel with one of the e's. So R is 1 by 4 pi epsilon naught times 50 times 1.6 into 10 to the power minus 19 into 2 divided by 20 into 10 to the 6, using this value as 9 into 10 to the power 9. So you will get 7.2 Fermi. This is the right answer. The next question says that which of the following use radio waves to transmit voice communication in the ultra high frequency band? So this is an informative question and you need to know what is ultra high frequency band. So ultra high frequency band is basically the frequency band between 300 megahertz to 3 gigahertz. This is the frequency band is used by cellular phones. But in the case of FM, the frequency range in the order of megahertz. For TV wave also megahertz, but for AM it is kilohertz. So the right answer is the cellular phone. So next we need to find out the resultant gate that is implemented by this whole circuit. So as we know, these gates are NOR gates. So after the first implementation of a NOR gate, the result would be A or B bar, and after the second implementation, the second NOR gate would take A or B bar with A or B bar and then takes the whole bar. So using the De Morgan's rule, A or B whole bar is A bar and B bar. So this can be written as A bar, B bar, whole bar and A bar, B bar, bar, whole bar. So as we know, P dot P is basically P, that is P and P is P. So the result is A or B. OR gate is the correct answer. Now the question is, you have a fixed charge with plus Q2 and a negative charge minus Q1 is rotating around a circle around the charge Q2. So in this case, the electrostatic attraction force will compensate the centrifugal force F. So we need to balance the electrostatic force with the centrifugal force. So omega square is 1 by 4 pi epsilon naught Q1 Q2 by m per cube. So as we know, the time period is 2 pi by omega. So we can write 4 pi square, because of this 2 pi, into 4 pi epsilon naught m r cube by q1 q2. So that would be 16 pi cube epsilon naught m r cube by q1 q2 square root. So option A is correct. Now the question is, a plane is in level flight at a constant speed, and each of its two wings has an area of 20 meters square if the speed of the air is 190 km per hour over the lower wing and 270 km per hour over the upper wing. We have to find the mass of the plane. Suppose this is the upper wing, this is the lower wing. There is a pressure P2 here, there is a pressure P1 here, and due to this pressure difference, the flight will experience an upward force F, which is balanced by the gravitational force mg to place it in a level. So according to the Bernoulli equation, we know that P1 plus half rho V1 square, where rho is the air density and V1 is the speed of the air below the lower wing, must be same as P2 plus half into rho V2 square. And we know force is, the upward force is P1 minus P2 into the total area of the wings, which is 2 into 20, that must be equal to the mass of the aeroplane times g. So m is P1 minus P2 divided by g times 40, and if I do the calculations using the above formula, I will have half rho V2 square minus V1 square, rho is 1, times 40 divided by 9.8 square. But remember, V2 and V1 are given in kilometer per hour, so I have to make 1000 by 3600 square into 270 square minus 198 square divided by 9.8 square, and if you solve this, you are going to get 5306.1 kilograms. Option C. So let me rub this out. Now the question is, a light candle which is of size 4.5 centimeter and is located at 30 centimeter in front of a concave mirror which has a radius curvature of 42 centimeter, and we need to basically find out what the image will be formed. So as we know, the mirror equation is 1 by f is 1 by u plus 1 by v. F is the focal length, u is the object distance, v is the image distance, and we know from the sign convention, focal length of a concave mirror is negative quantity, and in this case it is 21 centimeter, minus 21 centimeter. So 1 by v, and since the object is in the left side of the concave mirror, so u is also negative, and 1 by v is 1 by f minus 1 by u, which is minus 1 by 21 minus plus 1 by 30, and you will find out that it is minus 1 by 70. So V is 70 centimeters. Now the last question says that what is the relevant equation if object is at origin and with velocity I plus j. There is, in the official question, there is no I in the fourth option. So there is a mistake here, I'm sorry for that. So these are the four options, and we need to find out what is the relevant equation if an object is at origin and has a velocity v I plus j. So as you can see, the D option does not make sense because the R is a vector quantity, that is the position is a vector quantity, and these things has no direction. So this option cannot be possible, and for the other option you need to calculate the velocity first, so which is dr dt, and if you calculate this, then you will see this is 5t minus 1 plus j 1 plus 3t. Similarly for this it is 5t plus 1 I plus j 1 minus 3t, and for this it is 1.5 I plus 2t j. So now we have to see for which of these things, these three options, if I put t equal to 0, the velocity is equal to I plus j. So as you can see, if I put t equal to 0 in the first velocity, we will see that v is minus I plus j, so this is not true. And similarly for the fourth equation, if I put t equal to 0, then the velocity becomes 1.5 I. This is not the case. And for the second option, if I put t equal to 0, the v is I plus j. So option B is correct. So these are the things I want to discuss today, and if you like the video, please press like, share and subscribe, and I will solve the other 10 questions in the next video. Thank you.